Let's say we have these order pairs. Let's find their addresses. Here we've got 1, 2, 3. We've got a 0 and 3. And on this ordered pair, we have the 1, 2, 3. We have a negative 3 and 1, 2, 3, a negative 3. So m is equal to y2 minus y1 over x2 minus x1. We've got to choose our points to decide which point is first and second. So let's make this 1. Let's make this our x1 and y1. And then we'll make this our x2 and our y2. But it doesn't matter. You'll get the same answer whether you do it this way or the other. All right, so now that we've decided that this is going to be our second point, we're going to have to look at that one first and pull out the negative 3, negative, and go back to this one, 3. Negative 3, 3, divided by our x2 is another negative 3, and this x1 is 0, minus 0. So this is negative 3 is a negative 6. Negative 3, negative 0 is a negative 3. 2 negatives in division make a positive. So our slope then is 6 over 3. We can reduce 6/3 to 2, but for the purpose of the slope in our formula, that would be like 2 over 1. Now that means for every point that's on this graph, wherever we start, we can start right here. We can go up to 1, 2, and over 1. So that's up to over 1, and we hit a point. Up to 1, 2, over 1, we hit another point. If we go up to and over 1, we get another point that's on this line. So you can see that this looks like stairs that are going on the line. That is the slope. That's the change in y and the change divided by the change in x. And it stair steps it in a positive direction. That's why this line is going mostly in the third and first quadrant. Even though it snitches a little bit of this second quadrant, it doesn't stay there. The majority of the line, when you think about it goes to infinity on both sides, that would make the line predominantly in the first and third quadrant. And as you know, the values for the first and the third quadrant are both the same signs on each of the x and the y axis. Let's connect another set of dots. Perhaps this one, this pair. Okay, let's find the addresses of the points. Before we can understand the slope of this line, we have to understand the points. So we've got 1, 2, 3, 1, 2, 3, 4, 5, 6. This point is at positive 3 and 6. This point is at 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. So this is positive 9 and 4. We have to decide which point is our first and our second, so that we could do x1, y1, and we could do x2 and y2. We're now ready to do our calculation. M is equal to, we'll always start with our formula because it's much easier to do that, to get our formula out there to match the numbers. Now we'll insert our values. Y2 is 4 minus y1, which is 6. x from the second point is 9 minus x from the first point, which is 3. Now we're ready to do our math. 4 take away 6 is a negative 2. 9 take away 3 is a positive 6. We have a negative, this is a negative slope, that's correct because it's going this way. Negative 2, 6, we can reduce this or simplify it to negative 1, 3. So our slope is negative 1 over 3. So we're going to pick a point. We can do this one. We can go down 1 and over 3. 1, 2, 3, and hit the second point. This line is, the dot is kind of squishing it, but it would be like that. Okay, and then from that point, we can go down 1. See, it's a negative 1, negative 1, 1, 2, 3, and hit the other point. So here's our stair step in this case, over 3, down 1, over 3. So you find the slope by using 2 ordered pairs somewhere on the line. It doesn't have to be the end points. It can be in the middle too. You take 2 of the points and you decide which ordered pair is going to be your first one and your second one. And then you just put the values for the x and y pieces into this formula, and you will get the slope of the line. After you get m, that fits the m in the value of y equals mx plus b. So this value would be a negative 1/3 in this problem. And you can tell from this number right here that the slope of the line is going to be in a negative direction.